go. Wolverine Worldwide, a shoe company in Rockford, improperly disposed of chemicals, PFAS, that would be the type of chemical that they improperly disposed of, and it leaked into the groundwater. The state of Michigan says that if more than 7% of households in a city exceed the safe limit, the city needs to switch to bottled water. A concerned citizen takes a random sample of 100 households and finds that 12 have unsafe water. Do the data provide convincing evidence that Rockford should switch to bottled water? So what I want you guys to start off by doing is state appropriate hypotheses for performing a significance test and use alpha equals 0.05. If you're going to state the hypotheses, what do you have to do first? Yeah, define your parameter and then state your hypotheses. We have our alpha level here. You also need to give the test statistic here. And then down in number 2, I want you to interpret this p-value. We're not going to run the whole test. I want you to interpret that p-value. So I'm going to give you guys about 5 minutes to do those 2 pieces on your own. You may do it either completely on your own or you may work with a partner for that. But I want you to do number 1 and number 2. All right, let's go ahead and at least talk about number 1. If we're going to state appropriate hypotheses, we have to define our parameter first. What would the parameter be? Yes, the true proportion of households in Michigan that have unsafe water, or the true proportion of households in Michigan that exceed the safe limit, something along those lines. But that would be what our, and then what variable would we use for the true proportion of? P. So P equals, here we go, the true proportion of households in Rockford with unsafe water. So now let's state our hypotheses. The null hypothesis for proportions will always be P equals something. What should P be equal to? 0.07. So null hypothesis, the HO, is P equals 0.07. What would that mean? 7% of the households have unsafe water, which means like Michigan's like, that's okay, that's tolerable levels, or no. That's tolerable levels. It says the state of Michigan says that if more than 7% of households exceed the limit, then the city needs to switch to bottled water. So if P equals 0.07, then generally we're saying the water's safe, we don't need to make any changes. What would the alternative hypothesis be here? P is less than or greater than, or not equal to? Greater than. What was the test statistic? I'm asking. What was the test statistic? 0.12, 12 out of 100, right? Is that above or below? Above. So my alternative would need to be greater than. Because if there's less than 7%, do we have a problem? No. Only if we have more than 7% do we have a problem. And this citizen found, at least in their sample, more than 7%. So my HA is P is greater than 0.07. What would that mean in context? Water's safe or unsafe? Unsafe. General rule across the board. The city should invest in bottled water. That's not just going to those households. They're like, it's getting into everybody's water. We're all switching to bottled water here. All right. So the HO is that it's equal to 0.07. The HA is that it's greater than 0.07. You guys already told me the P hat is 0.12. What's the other thing that I need to have in the state section? Significance. So this one would not be a confidence level because we're not doing a confidence interval. It would be a significance level. And what significance level are we using? 0.05. So just to clarify here, confidence levels versus significance levels. Confidence levels are always going to be very high percentages. We want to be 95% confident, or we want to be 99% confident, or 90% confident. And then alpha level, significance level, this is always going to be a small number. And we'll talk a little bit more in detail about exactly what that alpha is today. All right, number 2, part A. After conducting a significance test, so they already went through and did the plan, do, conclude, they got a p-value of 0.025. So, sorry, they did the plan and the do. They've asked us to interpret what this means. If you found a p-value of 0.025, what would that mean? Assuming the null is true.
P equals 0.07, there is a 0.025 probability
Absolutely. Assuming the HO is true. So assuming the water is safe, because that's what our HO is, right? If 7% of households or less have unsafe water, then we say that generally the water is safe in this area. So if the HO is true, P is equal to 0.07, the water is safe. There's a 0.025 probability of getting a p hat of 0.12 or greater purely by chance. Let's pop that up a little higher on the screen. All right, so now I want to go through and do B, C, and D together. If we had a p-value of 0.025 and a significance level of alpha equals 0.05, would you reject the HO or fail to reject the HO? Reject the HO. So how would we state that? Because 0.025 is less than 0.05. We have convincing evidence that they should switch to bottled water, that the water is unsafe. There's a couple different ways. Oh, part of my stuff disappeared. So because, I don't know why my words disappeared here. Because 0.025 is less than 0.05, we reject the null hypothesis and have convincing evidence that water in Rockford is unsafe. So Rockford should switch to bottled water. This is kind of weird here, folks. Yes, I am recording. Yep, thank you. Thank you for checking. All right. So I want to suppose that that decision is wrong. We've made a recommendation based on this p-value that the water is unsafe, and we've told the city, you need to switch to bottled water. If that decision was wrong, what would a consequence of that decision be? I want you to think real world context. What would be a consequence of being wrong about this?
They're going to have to spend a lot of money on bottled water for everyone.
That's exactly right. They're going to have to spend a bunch of money on bottled water. Did they need to? No. We gave this recommendation, but it turns out that it was in error, so they spent a bunch of money on bottled water and they didn't need to do that. So they wasted money. The water was actually safe. They switched to bottled. This is what is known as a type 1 error. In a type 1 error, you reject the null, but the null was actually true. So in a type 1 error, you reject the HO, but the HO was true. If the water was safe, so if we made this error here and the water really was safe, like, what's the chance that I make this error here? Does anybody know? Very small. Anybody have a number for me? Close. 5%. That's what that alpha level is. That is the probability of a type 1 error. That's why sometimes you'll see an alpha level that's smaller, because the probability of being wrong on this would be really bad. So we need to make sure we're not wrong on this. The probability of a type 1 error is a number, and it's whatever my alpha level is. So that alpha level that we've been using, that thing that we've been comparing to this whole time from first semester till now, even though we didn't know it was called our alpha level or our significance level, this is the probability that we tell them to reject, but we were wrong. We can control the level of that mistake or the chances of making that type of mistake. We control that with our alpha level. So now I want you to suppose, so take everything in question 2 and like wipe it from your memory. Now suppose when they ran this significance test, the p-value was 0.217. Is that a reject or fail to reject? Fail to reject. Why? Yep. 0.217 is greater than 0.05. So we fail to reject the null, and we do not have convincing evidence that the water is unsafe. Rockford should keep their current water, basically. Let me pop that up higher on the screen so you guys can see it a little bit better. If we ran this test and we got a p-value of 0.217, so we fail to reject the hoe, we tell Rockford, you're all good. This was probably just due to random chance. We got a weird sample of 100 houses. What if we were wrong? What would the impact of that be? People would drink unsafe water. Would that be a problem? If people are drinking unsafe water, they could get sick or die. Like, this is serious. Failing to reject the null when you really should. So when the ha is true, but you fail to reject the ho, we call that a type 2 error. What'd you say? No, that's a good question. The type doesn't have to do with how serious it is, and I really wish they had better names for these, because type 1 and type 2.
Like, oh, this is real serious.
So they gave them the most boring names that are not intuitive at all. Because honestly, like, this is what, like, it took me so long to get this down where I wasn't confusing them in my own head. Type 1, you rejected the ho. The P was low, you rejected the ho, but you did that erroneously. That's a type 1 error. A type 2 error is like, you didn't reject the ho, but the ha was actually true, so you should have. Which thing is more severe?
I'm not evaluating for a second.
Okay.
How do you keep them straight? Because you always have like, logical.
Honestly, this one, to keep them straight, it's just kind of repetition.
Okay.
I don't have a good way because they named them so poorly.
Asking for a parent of an 18 class.
Right? I wish I had a really great way
Flashcards.
to keep them separate. Yeah, it's flashcards, really. So in this particular situation, which type of error would be more severe, a type 1 or a type 2? Type 2. Consequences in question 3 are more serious. So type 2 error in this situation is more severe.
What's an example of the other way around?
The other way around? Give me a minute and I will answer that question. Like, I know I need to have one on standby in my head. Give me just a second. My brain has too many words in it right now. If people are drinking that unsafe water, it could lead to health problems. We already said they could get sick or die, like huge, big consequences. The consequences of the other one is like, you spend too much money. Obviously, the city doesn't want to spend money that they don't need to, but that's not nearly as big of a problem as if the people who live in your community are getting sick and dying. Here would be an example where a type 1 error, in my opinion, would be more serious. You're working on developing a new drug, like when they were coming out with the COVID vaccine, right? And the consequence of making a type 1 error would be that you would say, this vaccine is no good, we're going to throw it out and start over. But it actually does work. The consequence of a type 2 error in that case, where you failed to reject but the HA was true, so you have some people getting vaccines that aren't necessarily doing anything to help prevent, but it's not hurting them either. So they get a shot that they don't need to, versus they throw out all of their work that could be helping people get better because they made a type 1 error. So that would be a situation where type 1 is worse than type 2. Does that make sense?
Yeah, I was like, it's not like deadly.
Yeah, it's not a deadly mistake in that case, but you're not helping people that you could be helping. All right. All right. Before we go over and look at the backside, what questions do you guys have? Yes?
So we shouldn't think of it as type 2 is worse, or we should?
You should not.
Okay.
It totally is situation dependent, which is why on this we went through like, what's the consequence if we reject the null and we really shouldn't have? Versus what's the consequence of we failed to reject the null and we really shouldn't have? They're going to have different consequences in each situation. And depending on which one is more serious, that's the one that we would want to control for more. So in this one, let's just pretend for a minute that type 1 was the more serious one. I can control for that amount of error by changing my alpha level. If I make my alpha level smaller, then I take the chance of making that kind of a mistake and I make it smaller. Type 2, we're going to get into more tomorrow as far as how to reduce the probability of making a type 2 error, but that's a tomorrow thing. So flipping it over on the back. All right, so we've got this nice little two-way table here. We have the truth of the situation up on top. So we have ho is true or ha is true. Then we have the conclusion that we reached from our hypothesis test over here on the left, to either reject or fail to reject. If the ho is true, but we reject it, that's a type 1 error. If the ha is true, but we fail to reject the ho, that's a type 2 error. These other two are great. You made the right choice. Here, the ha is true and you rejected the ho. That's exactly what should have happened. We made a right conclusion. The ho is true and we failed to reject it. Yeah, we should fail to reject it if it's true. That's a good call. This honestly is the best way that I can think of to try to keep these straight other than just straight up flashcards, is kind of remembering these pieces. If you can set up this two-way table, then you're going to be able to remember what your type 1 and type 2 are a little bit better. With a type 1 error, ho is true, but we rejected it. The probability of that is whatever our alpha level is. So if we were asked to interpret that, we would say the null hypothesis, and we would use context. So the probability that the water, not the probability, but null hypothesis. So the water is safe in Rockford. Assuming the water is safe, so the water is safe in Rockford, but we found convincing evidence that it wasn't. That would be how I would kind of explain a type 1 error. The water in Rockford really was safe, but we found evidence to say that it wasn't safe, and so we concluded that it wasn't safe. A type 2 error, the ha is true, and we failed to reject the ho. The alternative hypothesis is true, but we don't find convincing evidence for ha. I want you guys to take, how many minutes? Let's start with 5 and see if that's enough to do the check your understanding. If you'd like to work with a partner on that, please do so. but we'll start with 5 minutes and kind of see where we are. All right, so I want to know in context, what would it mean for the hoe to be true?
The coin really is tricked away and heads up 75% of the time.
Yep, coin works as advertised. It shows up heads up 75% of the time. What would it mean for the ha to be true? Shows up less than 75% of the time, so it doesn't work as advertised. All right, so that's the first thing that I'm starting off with. What was the sample proportion? You don't have to write that, but there were quite a few people that were writing down in context what that means. That does make it a lot easier when you're asked to describe what a type 1 error is and what a type 2 error is, if you can put the ho and the ha in context here. What was the test statistic? What'd you say? 0.70, yeah, 0.7. 35 out of 50, so 0.70. So do we have some evidence that it's not working as advertised? Yes. We haven't run the full significance test yet, but at this point, I want to know what a type 1 error and a type 2 error would look like. So I'm going to come back to this screen real quick, because I want to look at this two-way table. A type 1 error, the ho is true. What was the ho again? Coin works as advertised. It's up, heads up 75% of the time. But we rejected it. So we did or did not find convincing evidence. We did find convincing evidence that it didn't work. It really does, but in our sample, it was different enough that we found convincing evidence. You know how we say there's only a 0.02% probability that this happens by chance? In a type 1 error, we fell into that. This happened by chance. It's rare, but it happened by chance. All right, so that would be our type 1 error. Coin works as advertised, P equals 0.075, but the student finds convincing evidence that the coin is not working. That's our type 1. Now let's talk about a type 2. I'm going to come back and look at the two-way table again, because I feel like this two-way table makes it so much easier to understand what these errors look like. I would really work for the test on trying to recreate this two-way table and write it down so that you can keep the type 1 and type 2 straight. Type 2 error. The ha is true. What was our ha? Does not work as advertised. It's less than 75% of the time. What did the student find? Well, the student didn't necessarily find that it does work, because that would be accepting. Do we ever accept the ho? No. But we would fail to reject it, which means you would or would not find convincing evidence. Did not find convincing evidence in support of the ha. So a type 2 error, the coin doesn't really work as advertised, but the student does not find convincing evidence that the coin is not working. That would be a type 2. Which type of error would result in, your page says Mrs. Bolliton, mine says Mr. Wilcox, same difference. Which type of error would result in this person returning the coin and writing a negative review of the product? Yes. Oh, yeah. Type 2 would have you returning it?
Type 1.
Type 1. Why?
Because type 2, I don't know that it doesn't work. Type 1, I think it doesn't, even though it does.
Yeah, type 1 is, I found evidence that it's not working. So I'm ticked off and I'm returning it. This didn't work like you said it did. I want my money back. I'm going to write a negative review of your company. A type 2 error. What would be the impact of that? Yeah, you continue to use this trick coin, but it doesn't actually work as advertised. Do you think over time they'd figure that out?
Over time.
All right, so type 1 error here. We return the coin, sorry, that should say Mrs. Bolliton, returns the coin even though it was working as advertised. If the student were to use an alpha equals 0.05 instead of an alpha equals 0.10, would that make it more or less likely to reject the null when the null hypothesis is true? Less likely. Rejecting the hoe when the hoe is true is a type 1 error. So if we reduce our alpha level, we reduce the probability of making a type 1 error. Smaller alpha, smaller chance of type 1. Smaller chance of rejecting when we shouldn't. Yes?
When you're writing describing the errors, you don't, okay, I thought when you said context, you have to like talk about context from the passage or whatever.
Mm-hmm.
You just have to put like the number, like the hypothesis number.
It depends. Like when we're talking about context here, I would say you could use the numbers, you could use what it means. So like if I'm describing what a type 1 error is, I could say that I find evidence that the coin is not working as advertised when it really is. Or I can use those p-values to talk about that. As I'm describing a type 2 error, I could say that we didn't find evidence that the coin's not working, but it's really not working. So that would be another way. I would accept either one of those. Okay. All right. Do you guys have any other questions for me on type 1 and type 2? Work on that two-way table. By the time we get to the test next Wednesday, hopefully you are able to recreate that two-way table without looking at it. Homework 9.3 that you guys picked up yesterday, that's due on Monday. Tomorrow we're going to finish out the chapter, and I will also give you guys the review for the test tomorrow so that you can work on it over the weekend. Monday, after we grade homework, we're going to do an FRQ. And then Tuesday, I'll take questions over the test review. And Wednesday, we'll do your test over Chapter 9.